So, hi everyone. Hi Fredrik, how are you?
Yeah, it's fine. Thank you.
And I'm fine. So welcome everyone. I'm Pietro Manzoni from Polytechnic University of Valencia in Spain. So today I will be chairing this seminar. Today we will have Fredrik Ahlgren from Linnaeus University in Sweden. I hope I pronounced everything more or less correctly.
Yeah, it's fine.
And we already have some audience, people waiting for your talk. So today's talk would be related to IoT teaching, and basically Fredrik has big experience in teaching IoT courses, online courses with a lot of students, and I think he has incredible experience in this sense. And I think it will be a really interesting seminar. For those of you that are attending, we will have also time during the talk for a few questions. And if you have any question, you can type it in the chat in YouTube, and I will ask Fredrik to answer to those questions. So please, Fredrik, whenever you're ready.
Yeah, okay. So thank you very much for the introduction. And as I've planned this, it will be as much interactive as possible. That means that, well, if you do have any questions, please ask them, and then I can answer them right away and discuss them. But I'll actually start with showing a little bit of the roadmap we have here. And everything I'm going to share today will be an interactive. It will be live in the sense that I'm actually showing the material from its source. When I started preparing this presentation, I was trying to gather as much information into a keynote, and then I realized that this is not the way we do it when we teach the course, because we usually rely on actually using HackMD and interactive material. So that's why I'm using this as a showcase as well on how we often do things when we're teaching in the course. So I'll start with, say my name is obviously already told, and I am from southeast part of Sweden, and we have a university there by the sea. It's called Linnaeus University. It's in the city of Kalmar. And we've been running this course, especially IoT course, for the last 4 years. So it's actually been quite some time. In this sector, it feels like a long time, I would say. Anyhow, I will start by describing a little bit about the background of the course. We do have, I would say, we had an idea of creating an very much an applied IoT course, and it would be in a summer setting. And 2019, we had something called the Linnaeus Summer Academy. We had a quite large influx of students from Asia that came to Sweden and were studying at the summer university, a lot of courses. So I've been teaching in those kind of courses previous years, and it's a fun experience. So we developed this course to be a course that anyone could enter without having a computer science background. So that was one thing that was a little bit special about this. You didn't need to have a prior programming experience, and well, actually no experience in electronics. You just needed to be able to study on a university level. That's about it. So you could be a high school teacher and you wanted to learn more about IT. This could be the entry for you. That was the background and idea of the course, to make it as applied and lab focused as much as possible, to be on campus, meet the students and do things together. We'll build something. And also with very, very low requirements of previous knowledge. It should be available more or less for everyone to do. And yeah, COVID struck us all during 2020, and we don't need to dive into that. But at that time, I was actually working in Canada, and I got a question that maybe we could make this course a distance course. So everyone transitioned, the whole university system sort of transitioned into distance mode during early spring of 2020. So Petro, you might also remember this very well. But this was no exception. We had this summer course and we formed it to a distance course. And in some sense, I think this is a quite important backstory of at least this specific course, is that when we developed it from the beginning, it was developed as a hands-on lab-focused course. We should do things, we should build things, and we should, the end product would be that they built some kind of device, and we had a lot of workshops, and we should have fun, meet each other. So when we formed this into a distance setting, we couldn't really rewrite the full syllabus. Everything was sort of squeezed into a distance format. That meant that we kept sort of the main idea of the course, but still just transitioned to distance without having any idea on how to do this best. So the last 4 years has been a journey. We have done things differently every year, and not everything has been great, but a lot of things have. So I'll talk you through the different changes and the journey. But just so you understand is that we have focused a lot on creating video material and also trying to engage people as much as possible. The first year, the course was actually in Swedish. So it was a Swedish course, which seems kind of strange when I think about it now. But this is how the first course introduction, you won't hear the sound, but this is how the first course introduction was made. I was sitting on the beach in Vancouver, we had these PICOM devices, and I talked, and we had also Francis Palma, a colleague. He were in Kalmar, Sweden, and then we had a couple of students. We introduced everyone, like in a quite informal format. And then we just went off. I think I showcased a couple of sensors, like you see the PICOM device here and ultrasonic sensors. And
I'm sure you will talk about this. Sorry to interrupt, but it wasn't the need for the student to handle real hardware was kind of more the most critical problem.
Yeah, exactly. Yeah, it's good that you mentioned this, because that was one of the biggest challenges we had, because if you have students coming to the campus, well, you can just arrange that there are devices in the lab, and we're used to this kind of setting. But if you're going to do this distance, well, the students need to buy the hardware themselves. And we wanted them to learn LoRa. That was one of the things that we had in mind. Like it should be, we should include LoRaWAN, and we should still keep it simple so everyone could learn. And as you saw in the video, we used the PICOM device for the first year. And this was a problem because getting hand of, it was actually hundreds of PICOM devices. We had the first year over 1,000 applicants. And then we're talking only Swedish-speaking people. So it's quite a good number actually for a summer course. So they all had this start kit, which included a low Pi 4 and a couple of sensors. I think it was a DHT11 sensor and like a temperature and humidity sensor, but everything was quite inexpensive. And we used MicroPython for this. And then these are just some examples. and this is just a general theme. Now it's a tradition, so I will probably continue. But every welcome video is filmed in a new setting and always in nature. So this is actually in Denmark, by the way. So the first was in Vancouver, and this is in Copenhagen in Denmark. And last year it was on Öland outside of Kalmar. But we've always had this, like, tried to have this engaging introduction when we start early on. And this is also something that you need, I think, from a teaching, from the educator perspective, is that when you're working with hardware, as you said, Pietro, people need to buy things. And you can't start the course, but like the first week of the course say that, oh, then also you need to buy things. Well, then 2-3 weeks into the course, they might have not received their gadgets, their stuff. So they need to buy it well in advance before the course starts. And this is quite interesting, actually, because, well, you need to reach out to the students which have just applied to a course, and they apply in February, March, around that time. The course starts in June, so it's a couple of months in between. And at least in the Swedish university system, there aren't really any like formal and good ways to contact students which aren't like in the system.
Oh, yeah.
Yeah. So yeah, you can find ways because we have an admission system, but then you need to actually manually go in and fetch like their private email addresses because they haven't yet been onboarded into the university system and gotten their student credentials. A lot of them haven't. So it's a little bit like you need to go a little bit outside the boundaries of what you usually do. This is one of the challenges. So I have now, I've written, the last couple of years, I've written a Python script that does all the emailing. Just because, yeah, and obviously last year I automated this and made like a personal message to each student. So it was a little bit of personalization in that script. So it's been a little bit better every year.
Yeah, we have to remember that you're handling hundreds of students, so you're not just 40 students. So
yeah. But these are challenges that are, I would say, fun to work with, but also like you need to think a little bit outside the box. There aren't any university systems that, at least that we have, that can sort of do the communication in an effective way with students that haven't yet been onboarded. Because we always think in boxes. When they are students, we can contact them, they're in the learning platform, we can give them grades. But if they're outside and it's still not in. So these things needs to be handled when you have something hardware related, also communicating with a lot of students, also now from different countries. I would say that after 2021, we made it an international course. So we now have students from all over Europe, and I would say all over the world, even though I would say Europe is 99% plus something. We've had like one student from Africa, I think, and maybe one from the US and one from Asia. But it's the problem is that they need to pay. So I mean, it's understandable why pay. I'm actually saying this out loud now. You shouldn't pay for this course, as everything is sort of free anyway. So you could audit this course without any cost. But we are going to the platforms later on, but we've utilized Discord, for instance, to create this engagement videos and such.
So why you chose Discord? Just it was one of the alternatives, or?
Yeah, we did in the early beginning. We started actually using Slack. So we onboarded all the students the first year into a Slack server and a Slack channel. But Discord quickly became the new choice, and it was on demand from the students. And this was already the first year. We started at Slack, but then quickly, well, I would say halfway through, transitioned over to Discord. And the main reason why Discord is working better is that you can keep all the workshops, the video, the discussions, everything in one place. Slack is not good at video and audio and group settings. Discord is sort of made for this. I mean, gamers use it for communicating. So it's a really good way of doing this a little bit more interactive. And then we talked about the hardware, so we can skip into that. We're already 16 minutes into the presentation, so yeah, if you want to interrupt me, it's fine.
Yeah. I mean, there was a question before, but I already answered about, which maybe can be related. So you suppose that they were asking that what level of knowledge of the participant do you have? If they coming from technical fields or from other fields. In your experience in your online courses, which is the percentage of people that actually had a prior experience in programming or electronics, and if there was a high percentage of people that didn't know anything about those?
Yeah, it's a really good question, and I can give you some rough estimations. I can't say a definite answer because we don't check. But I would say that about 50% of the students, they do have prior programming experience and of some kind. We see a lot of students that are coming from the industry, that they are working in IT companies. They might be working as developers. And we have seen senior developers that work in big companies and have a really, really long background in programming. And we have also a lot of students, I would say, that have really no prior experience at all. They are interested, so you don't really apply to this kind of course if you're not interested. So that's probably all of them have some kind of interest. Otherwise, it would be sort of strange to apply for an IoT course. But we have a lot of students that they have never opened an IDE before, a development. They start by thinking it's like they open Visual Studio Code and they see a black screen. They are used to things that are white and not black on the computer screen. And they haven't written a single line of code before. It's fine. Even those students manage to do the course. And that's really the point. It's not focused on programming. We give an introduction, but it's not an extensive introduction. And then you help them out by the workshopping instead.
Maybe it's a matter of joining pieces of providing already software and say how to join the software together with the hardware.
Yeah. So, but we've seen some, and the thing here is that you are able to put a project which is, like I would say, if you're really into IoT, you might think it's very, you might think some of the projects are trivial, and yes, they are. I mean, a lot of projects are temperature and humidity for your greenhouse. That's a very classical example, and it might be some wires on a breadboard and things are just displayed on a low-code solution on a dashboard, maybe data cake or something, Adafruit or something like that. And if they are able to do that, if they're able to write their report, which I'm about to tell you a little bit more about in just a minute, then they can get a grade that is pass. So the lower requirements for passing the course is actually quite low. I mean, you can sort of come away quite cheap if you think about it. But the thing here is that most students don't. That's the interesting thing. This is one of the kind of courses where it seems that people are actually joining in to learn rather than just getting their grades.
Yeah. So it's a great advantage.
Yeah.
No, I was asking also that because sometimes when you have to define the level of your course, if you know the background of your student, then you can say, okay, my limit, I can suppose that they can reach this level easily, and then I can move up. So having such a high variability, maybe you don't know which level. So if you're being too simple, or if you are being too complex. So
Yeah.
finding the right way to present some subject can be difficult.
Yeah, and it is difficult, and you always try to adapt. That's like what we do. But I would say the lectures are both high level and low level. I mean, we have some basics in the lecture material, so you get like how to get started, etc. But we also are focusing a lot on the high level. How does LoRa work? I mean, that if you're a beginner, maybe that is a high level. And we also have a lot of industry sessions. There's a lot of golden pieces still left. We have talked about TinyML, for instance, in this course, that are still in the course. So, but otherwise, that is, yeah, as we do have all these workshops, we have workshops all days of the week, even weekends, daytime, and even late at evenings. I can show you an example of a schedule if we.
So what should you mean? What should you mean? Specific sessions dedicated to a very specific topic?
Yeah, we have sort of clustered them in week 1, 2, 3, 4. So week 1 is more about assemble hardware. So the workshops are made in that way that we have a team of, last summer we had a team of 10 teaching assistants. So it's a little bit of a project itself, so just to manage all these people. But the thing here is that we have 10 teaching assistants. They go in and plan, so they plan themselves. It's sort of made as a decentralized planning system. Actually, the students in the course are also able to say that, oh, I would like a workshop at that time and that time. So it's a little bit of decentralized voting system as well. But anyhow, first week, we spend a lot of time on assembly hardware. In the Discord server, there are different workshop channels where there is a theme. So the theme could be that one teaching assistant is sharing their screen and, well, just showing, okay, now I'm clicking at this button, now I'm installing Visual Studio Code, now I'm doing this, now I'm doing this. And people can join in, they can listen, they can talk. It's not a lecture, it's more of like show and tell workshop. And then there might be 4 other teaching assistants that are in the server at the same time, ready to jump in. So if there is a discussion that pops up, they could say, let's break out to this room and then continue. And then you see that there is like some people that just jumps over to that one because it's maybe a higher level. And as long as you have these teaching assistants that are, if they are really engaged in what they are doing, if they love teaching, if they love like spending time on the computer and helping out others, it actually works without having this formal structure. So I think that is also one message here, is that it can be done in a very informal way if you just give away a little bit control down to teaching assistants and students. And so, and this is a perfect example of a course where I, as a course administrator, have very little detail control in the end. It's also would be more or less impossible for me, as there are 13, 14 people involved in the management team of the course. So
So I avoid micromanagement at all, and then
but if we talk about hardware, maybe this is something that you could always have opinions on this, and we could probably spend time on. We could have a full hour session only talking about hardware. I'm sure of it. But it's I think this is at least important to talk about, and this applies for, I would say, not only a distance setting or a lab session on a campus. I think hardware always evolves. We've seen that 2019, 2018, and also 2020, PyCom was a really good way to start learning IoT. I think what PyCom did at that time was great because they adopted MicroPython which is Python for microcontrollers, essentially. For those of you that don't know MicroPython, it's Python on a microcontroller. And they adopted this and made this hardware called PyCom. And it's an ESP32, and they also had this nice little device with an LoRa chip as well. So they have this low pi 4. So then you had LoRa, you had Wi-Fi, you had Bluetooth, and you had MicroPython. Well, it's a very, very good start of making it easy and available. And I think this is, at least from my perspective, one of the most important things, maybe not PyCom itself, but MicroPython for IoT courses. It might not be super hard to work with Arduino, and Arduino is great. I love Arduino as well, but Python is more available. Like it's easier to get started with Python than C++. It's no question about it. And we want to onboard people from everywhere. The same applies if you might be a web programmer. You might know your way around JavaScript. You might know your way around Python. But C++ might be something that looks a little bit awkward and you don't want to play with it. If it's MicroPython, you can do it. And also that you have an interpreted language. That means that you have the Python interpreter running on the device. This gives a new way of, I think a new dimension of how you interact with hardware. And that is also super important. When you don't need to compile and then upload the firmware every time you do a change. Instead, you can actually work with the REPL and line by line, just turn on a LED, turn off a LED, read a value from a sensor. That kind of programming is also something that I think is really important for learning. You can iterate one step at a time.
No, definitely. There are a lot of people that hate Python, but because of efficiency, this is very slow. It requires a lot of memory, but I think, as you said, you have to understand the objective that you have. You want to teach how to do something. So
and but I do agree. I mean, you always have compromises in everything that you do. But anyway, we started with PyCom. We transitioned in year number 2 actually to using just ESP32 development boards and then Heltex. Not very easy to, essentially we've been working with ESP32s because PyCom is that as well. But the thing is that PyCom actually was in trouble 2022. They weren't able to actually make devices for all the students. And the downside with PyCom was also that they were always a bit expensive. So a lot of students ended up paying almost 100 euros for their starter kits. And it's actually quite pricey. I mean, you could argue that, a textbook in any computer science course might also cost 100 euros, depending on, but if you don't download them in PDF from, but anyhow, there are there are inexpensive devices out there. And we also saw that most of the students are actually not using LoRa either. Even though we wanted them to do, we couldn't sort of say that they needed to. I would say that the advanced projects, yes, they did. But so we started the transition to less expensive hardware. Health tech devices were really good. I still think they are good, but they are a little bit harder to get hold of because you need to ship them from China, and there are distributors in Europe as well. But yeah, you don't get the same kind of distributors, I would say. No, you find them on Amazon and a little bit others sites. And then last year we introduced the Pico, And it should be a W after the Pico because we use the wireless version, obviously, as it is an IoT course. But and that has worked really, really good.
I think this is a very cost-effective device because it's very cheap. Even here in Spain, it can be bought for 8-9 euros, something like that.
Yeah.
So, and you have Bluetooth, you have Wi-Fi. You can use TinyML. You can do some experiment with TinyML. So I think it's very flexible hardware.
Yeah, and if we look at the start kit that we have worked with the distributor, the students are essentially they can buy whatever they like. I mean, they actually, as long as it's a microcontroller, they are free to choose. So it always been in the course that they are free to use their own hardware. So this is a recommendation rather than a requirement to use a Pico. So we have seen students using PyComs and ESP32s, and there might be other devices that I don't know about also in the course, but the Pico is obviously the choice to go. But this is how the starter kit have looked, at least last year. So you get the feeling that there is, it's in Swedish though, because it's a Swedish distributor. But there are Hall effect sensor, temperature, a magnet, there is a DHT11, there are some resistors, some wires, a USB cable, and then a breadboard. So the very basic kit, it's, I would say, very basic, but you're able to, with, I think, I'm not sure what this was priced at, but I think it was less than 30 euros, maybe 25 euros or so. Which makes it very, very much available for anyone to join in.
So no LoRa device, or it was an optional?
We had the LoRa device. So if we look at the bill of material, we did something called an add-on kit. So, and this was our way to go modular. So we utilized LoRa M5 stack module. And then you're able to, just via serial communication and 80 commands, use LoRa. So because the Pico doesn't have LoRa built in, so then you need to add that. There are other ways of adding a LoRa transceiver, obviously, but we think that the M5 stack is quite a good option because it looks nice, it's plastic, and it's very modular. And then if we look at the learning platforms, we've obviously been using YouTube, and those of you that are following this on YouTube, I can tell you that if you just Google the IoT and LNU, you might actually find all our playlists, because there are some golden nuggets in those lectures. We've had especially the industry talks. We've been in discussion, like we've had invited the Things Network, and we've invited Helium. Pietro, your lectures are great. You have been on, so there've been many, I would say, interesting and good lectures that are still on YouTube, and you find them on the YouTube playlist. So all lectures, all material has been open. I'm just saying. So this is a course, you could actually follow this course even though you weren't applied as a student. You could audit it. And then we used Discord, as I told earlier, is that this was the way of keeping it as interactive as possible. And you might think that why don't I show YouTube for you? I actually can't, because I will show a lot of names, and this goes directly onto YouTube. So no, I think it would be unfair for those. But those of you that are interested in joining into the Discord server, I will put a link in the description to this stream, and you're actually able to join into our Discord server, which is now 4 years old, and includes over 1,000 people. I would say 1,500 if I do remember correctly. So it's started to become like a community. Obviously the community more or less lives only summertime when the course starts, but it's a good way. And then Canvas, yeah.
One thing about Discord, my opinion is that when you start accumulating channels and resources, it can become like, so you get there and open the Canva and you get lost. You know, where I start, where do I start?
It's a mess. And the thing with Discord, I would say nothing is perfect, and Discord is far from perfect. It's a complement of using that together with other things. But it is hard to, I would say, we have about 400 students that we enroll into the course, and then there are 200 students that are active. So 200 students that all are active 5 weeks. And when I say active, that means that they are in workshops. Not every day all students, but every day there is a workshop, and there's lots of students. They're asking questions, they're answering questions. Yeah, then doing this in a forum on Canvas or whatever other like discussion forum, it wouldn't be the same thing. It would be something else.
Yeah.
So Discord is a way of like, but not good for static information. You are overwhelmed by the number of messages. So it's also very stressing for the students. We know that, we've discussed with them. And so, but still, I think it's the best way of doing it. With all the downsides, it's still the best way. And we can see that in a lot of internet communities today, they are using Discord as the base of communication. It's a nice way. And in the early beginning of internet, we had IRC chat. So Discord is more or less the same. Like if you know IRC, then Discord, it's black, but IRC was often white, I think. But
it was very widely.
Yeah. But anyhow, the Canvas, I would say, we more or less use these. These are open pages, so you're also very much welcome to just look at them. But we use them as static websites. We don't use. It could have been any websites. That's what I'm saying. So that's what we mainly use our learning platform for. The Canvas. And Canvas is one of many learning platforms, but you could have used Moodle as well, or just any static website, I would say.
Yeah, I think that depends on the university. My university has another platform which is kind of static, but then you can offer content, but it's nothing compared to Canvas or Discord, so it's just very static platform.
Yeah, we use the like Canvas in this case. We use it for the grading process. So when the students submit their work, like we need to do that grading, and then they are automatically connected with the student credentials and everything. So, in that case, the learning platform is actually a good way of making it simpler for the administration. We also have used it for quizzes. So quizzes and like handing in your report, but that's about it. So we could essentially have done the course without a learning platform. That's what I'm saying. It could have been a static web page anywhere and a Discord. So we are not dependent, so to say. It's only for the grading. But I would say that what we're doing in this course that are different, like from a lot of other courses, is that we focus very, very much on the practical experience, on the workshops. That is like we're pushing everything into that. So even to the extent that I sometimes feel that maybe we should have more theoretical lectures. But the thing here is that it seems to work really good. Students are happy and they learn a lot. So we're trying to sort of, what happens if we tell them to build things without saying exactly how they're going to do, and then we give them a lot of workshop options to actually work together with others. They find out how it works, and then you help them. So instead of having this very structured, like connect this sensor exactly this way and connect that this way. We try to make it more problem oriented, and they are like supposed to explore their own project.
Okay, regarding that, sorry to interrupt you. I have a question in the chat regarding what you actually almost answered a little before about how do you organize these workshop sessions? How do you organize the dates or the sequence of this workshop? If it's on demand or it's based on, I don't know, which criteria did you use?
Yeah, we work. They are. I would say they are not on demand. We have put up. We make a schedule. So if you look at this schedule now, I mean, we have one workshop here on Thursday. There are at 1:10 to 12, and then one actually, and then there is one actually at the evening as well. And so we put them on the schedule, and we have like general themes. So like the first week, we tell them that this week is about assembly of hardware. So this week you're supposed to have like an LED blinking. Like that's the goal of this week. And then we put up workshops. The students are free to join all workshops if they want to. They can also skip out on everything, but then they sort of lose the gist of the course.
Yeah.
Like if you join into the course and don't spend any time in the workshops, you could have, well, you're fine to do it, but I mean, why join the course would be the next question. So, but what we see is that we have a lot of students that are using the workshops as a way to learn. And the interesting thing, and this is just an interesting thing to tell, because I was a little bit surprised when this happened. On demand, there were students asking for silent channels in Discord. And you might think that it's very strange. Why would you have a voice channel which is like muted? You can't actually activate your mic. It's silent. So you go in there, and that's the only thing. The only thing that happens is that you're in a blank Zoom room or a Google Meet or whatever. Yeah,
virtual silent room.
Yeah, but the thing here is that you see a lot of students, they want to focus on studying. They might want to, okay, now I'm going to work. They jump into that silent channel. There might be 10 other students in the same silent channel. They can't speak to each other, but they get a feeling of belonging, working together with others all over Europe. And that is something that it obviously it's a thing, but it's super cool.
Yeah, well, yes, cool. Or I don't know if it's boring. I mean, if you need to be in a silent channel online to feel, well, I don't know. I mean, it's maybe it's for young people. It's the way they are used to be connected somehow. Or maybe it's a new way to work.
Yeah, it was new for me as well. But we have a couple of these. I think there are 1 or 2 silent channels, which I think sounds useless, but they obviously aren't, because they are used. So in some way, I would say that the core of the course is now that we have teaching assistants, and as we've run this course now for a couple of years, there are now a big number of people to recruit teaching assistants from. To become a teaching assistant, you need to be a student at a university in Europe. That's about it. So we've had students working as teaching assistants from Italy. Last year we had a guy from Italy working in a Swedish course and getting a Swedish salary, actually, as an Italian student. So that works. And that's also stretching the boundaries of what you usually do. Because I asked the HR department, are we able to employ people like students from other countries? And they, but we've never done that before. But yeah, it's possible.
Yeah.
And that also creates this kind of community feeling that you do the course, and next year you actually might want to be a teaching assistant, and they are really engaged and getting paid for it as well. So that is I would say the most special thing and the most fun thing of the course.
Yeah.
We do weekly blogs every week. So that is also a way of when you have that many students, we try to talk about everything that is happening in the course. And one thing that is also fun to mention, which is also, I would say, us trying to do things in a different way, is that the last 3 years, we've had a live stream which has been 12 hours long each. So, and yeah, it's a bit of a crazy idea, but we started this in, this is a couple of years ago, but the idea was let's talk about IoT for 12 hours. And the first year we thought we were going to do this for 24 hours, but it wasn't actually possible because YouTube cuts it at 12 hours. So we had to. But anyhow, then we've done a lot of material. We had interviews. We had people visiting us. We had the actually rector of the university. We built the 3D printer, and everything was slow TV or like things happening in a steady pace. People were able to join in or not. It wasn't any learning material that was obligatory. So you could watch or not watch. It's up to you. But we do it because we think it's fun. And we've done that for all years. So that will most likely happen again. And actually 2022, we also went to Dublin. So there was a conference in Dublin. Which also was quite fun. So this is a colleague actually talking at the conference in Dublin during that live stream. So, and we have about 50 students each year that is following from start to end. And I sometimes think that, well, don't you have anything better to do? But you could ask the same thing about us doing the stream. So, but we've actually had really much fun, and we are also trying to do as much fun projects as possible. So for instance, if you have 12 hours, you are able to showcase a 3D printed project, an IoT project from beginning to the end. So, and that's what we've done. So in this case, we are using the PCB printer. We have designed the things with the 3D printer and designed them in the lab. And trying to do this in a lecture, like you need to be very condensed and you need to make it structured and so. Yeah. But if you have 12 hours, you could just do, and then you could, it didn't work as expected, and then you solve problems, and then you could have a totally different engagement, and the students that are watching, they can also ask questions, and then we also engage a lot of people in this from the university. So I wouldn't actually recommend anyone to spend time watching.
You can do once 12 hours, but then every day 12 hours.
Yeah. But it's just I would say it's a way of showing, well, you that watches this stream, like how we approach distance learning in this course is that we try to do things because we think it's fun, and we first-hand fun, and then we try to find new ways of doing things, and we just adapt. So doing a live stream 12 hours in a university course, well, why not? Yeah, it's fun. And I can show you, this is something also that might be worth showing, is that we have this Hall of Fame. It seems that 2023 is, I need to check that because it should be 2023 here as well. But anyway, there is a lot of projects that are, I would say, really good. So we have a lot of fantastic student projects that has been done during the years. And these are the showcased projects, just to say. So 200 projects, there are a lot of projects which are more or less the same. So I would say these are the ones that we have.
Yeah, this is one of, so we have, because there is one question in the chat, if about evaluation. How do you evaluate student?
Yeah, that's also a really good question, because we had the same challenge. Like, how are we going to evaluate 200 student projects when they do a project? Yeah, obviously you could read all the projects and grade them, like as you usually do, but it's not scalable. So the thing here is that we want to put as much work time as possible on helping the students doing workshops. The grading process, that is, well, if I can skip that all, skip the grading, I would be happy.
Okay.
I think a lot of other teachers in the world would probably agree.
I agree.
So yeah, so we try to streamline that as much as possible. So we do a peer review. So we have a very structured way of writing the tutorial. We call it IoT tutorial, but this is actually the report. So this is the guide. So this is a pre-recorded guide on exactly how to do it. And then all the students need to follow the structure of this template. So it's just a template. They copy that, they Control-C, Control-V, and they copy that into their own GitHub or HackMD. Lots of students use HackMD. And they then go into a peer review. So all students are randomized and needs to check 3 other students. And what they do check, it's very simple. So as we have 200 students, it needs to be super simple. Still, we get a lot of questions. But the only thing they need to do is they need to count the checkboxes. Do they have a title? Yes, 1 point. Do they have their name and student credentials? Yeah, we're up to 2 points. Short project overview, 3 points. How much did Psych to do? Yeah, because that's something, yeah. And obviously, and then you get a point system. And all the points, like, it's very straightforward for someone to peer review someone else's work when you're just counting checkboxes. Okay. And that means that you get 3 students that all have counted checkboxes. And you get 1 student has gotten 20, 22, maybe 24 checkboxes. Then you, as an examiner, you can go in, you can skim through the document. You obviously have to read it, and that's why we have PhD students, by the way, because we have them in the course as well. So there's someone reading everything, but it makes it very much more straightforward. You actually take away a lot of the hassle of people forgetting things, and this is also worth mentioning because it's very important. The HackMD document, they put in a link. They don't submit a document, a PDF or a Word file into a learning platform. They put a link. They own the material. They can actually change that document all the time.
Okay.
That means that in the peer review process, the students are told that if you find something that is strange, well, if you find something that could be better, you tell the other one to make it better, and you will help them. Okay. And most of the things that are dumb mistakes, like you have forgotten to written whatever, and I forgot that one, or someone says that I can't understand what were you written here. It's sorted out just in this kind of decentralized way as well. Yeah. So when they actually do go up for grading, when you actually check them later on, most of the things are ironed out already.
But the process will take a few days, because if it's so interactive, then you will have, maybe it will give 1 or 2 weeks for the overall
3
days.
3 days. So we have a 3-day peer review process. So a lot of things happen during those 3 days. Okay. But obviously, you always, as you have that many students, there are always people that don't hand in time and etc. etc. So you need to have an extra round and such. Last year we now have ChatGPT. I mean, we 2020 we had COVID. 2023 we had ChatGPT. So, but the thing here is that previous years we've the projects that have aimed for an A and B grade, like a higher grade, they have been forced to do a presentation online, and we've had these presentations for all projects that have been graded higher grade. In this year we had presentations for each and every single project, and that is because we sort of needed to do that, because I mean ChatGPT could obviously write this kind of tutorial, and how are we ever going to be sure that it's the student that are making this or not if we are in distance? So the least we could do is that they also need to present. They need to show their faces. They need to talk about their project, and they need to hold something in front of the camera.
Yeah, to see if it's true or not.
Yeah, and yeah, you could. So that we did last year, and that is very, very time consuming when you have 200 students. So we divided this into subgroups, and we had parallel sessions. It was almost like a conference week. So we had Monday to Thursday full with presentations, and
Well, that's time consuming. That's
it is. So there are those things that are, I mean, but I think that we found a way to scale. We've made it as effective as it can be. We use Discord, by the way, even for the presentations.
I think we have a couple of minutes. I don't know how you want to.
Yeah, we can. I think I have some more points. I'm just going to mention. I mean, this is just we are. I mean, the Discord server, it contains a lot of messages now, because we've been running this course for a couple of years, as I said. So there are over 12,000 messages. And actually, there are much more than that, because the messages that are public, there are some hidden groups and such, like the TAs are talking to each other without students seeing and so. But there are a lot of messages. So we are publishing an article in Educon. It's a conference in May. So this is like a sneak peek at the findings. But anyway, we used ChatGPT and GPT-4 to analyze what has been happening in the server, like all these years. Well, like we're trying to develop a new methods for course feedback and such. That's like the main point of the article. But the sneak peek of this article, we could probably speak more about this in a later session, but is that most of the questions are about the online learning platform. So, whatever. I mean, I think it's quite fun actually, because I mean you teach a course in whatever subject, it could be whatever, I think. And most of the questions are about how to communicate, or when's the next lecture? Like that could be a question, which is probably
very practical, down to earth question.
So I think that maybe it's more or less it in terms of.
I have a couple of questions. Do you think we have time for a quick answer, or maybe
let's do it? Yeah.
One question is, if did you have any student that drop out because they understood they were not able to keep up with the classes?
Yes. So we I would say plenty. And in distance setting, I think this also is different in different disciplines. I wouldn't say that I have the general picture, but I think that you usually say that if you have 100 applicants for a distance course, about 25 is finishing. like you have a lot of dropouts just because it's distance. People, that's at least in Swedish. In Sweden, I don't know how it is internationally. But
so 75% drops
yeah,
out?
but we have had better numbers than that. So we are about 50%, I would say. So we have 400 students, more, like generally speaking, that are starting the course. And then we have an advantage which many other courses don't, is that when they buy hardware, they are quite committed of finishing the course. So you could probably say the same thing about buying a textbook, but I think hardware is even more like you are like more intrigued of playing with hardware than reading that book. So we keep quite close contact with the distributor, because, well, they need to know how many students there are. They need to they usually take 200 kits. That's usually what they sell, and we have about 180 students that are being examined. So I would say 20 students, maybe, that drop out, which is nothing, and then some of them are actually maybe coming back next year. So
okay. Well,
but I would say 50% drops out. Like they are, they apply for the course. They are
they don't even start,
but they don't even start. But so.
But if you consider those that actually start, they buy the material, so it's about 20 out of 200, so 10%. So it's, I mean,
exactly. It's a rough estimation. Still, I think you could probably find like a bet, but it's about that, yeah.
Yeah, and the other question: if do the students bring their own proposal for projects, or do you provide topics?
They do themselves. So we provide the topics in terms of that this could be good topics. We give them the list of previous year's projects. We give them some inspiration of like go in and check hackster.io and like explore your interest. But generally speaking, now they need to choose their own project. But also, if a student that doesn't really know what to do, because some of them are beginners and it's not that easy always to think of the exact right project. If they buy the start kit, it will be something that includes temperature and humidity, and it will be including some kind of LED. And so I'm saying that a lot of projects for, I would say, the lower end of the complexity level are the same things that you find in the start kit. They visualize some kind of data, temperature, humidity, and maybe have an LED that sort of does.
Do you remember the best project? Something that impressed you?
Yeah, we had a really cool project last year. I think it was a connected coffee machine, which was we spent a lot of time on that. Otherwise, I need to check on the list, but there are some projects which they go over, like they go beyond what you think that you might expect. We had a student 2 years ago. She built her own robotic vacuum cleaner, and it was it could be a master thesis. It was a really good project.
Like a Roomba,
Yeah, and she did the woodwork. So it was not only electronics, also the woodwork. So we've seen smart beer coolers with woodwork. Some people have like their own wood shops, and they want to learn about IoT, and then they combine that. We've had people working in agriculture, maybe as surveyors or like and I would say experienced people, and they want to learn about IoT. So they go in and I think we had some guy that were doing GPS tracking on trains, and he was working professional with these kind of questions. So he developed, it was a PICOM device, it was a GPS sensor, but spent a lot of time on visualization and data analysis to get what he wanted from this project. So yeah, that's the fun thing, is that if you have these people that are, I would say, really into an area, and they are knowledgeable within their domain, and then you just give them like the entrance into IoT. It doesn't need to be super advanced. Okay, because they will find a way. Then you could make wonders, I think. So, and that's what we've seen. So,
okay, what do you want to do? More questions, or
if there are more, I could answer them. Yeah.
No, I had a question at the beginning because as I told you, in 2 weeks I will start another course here about IoT, and what took me more time was to decide what would be a must to be presented in an IoT courses. And what is kind of not necessary. So which are the protocols, which are the technologies, what is mandatory, what you must know to start an IoT project. And then future, you mentioned before TinyML. I think it's probably nowadays it's something that should be at least mentioned in any IoT courses. So if you can comment something on this.
Yeah, I mean, in terms of IoT, I mean, one thing that I personally believe is like essential in an IoT course is that you work with hardware. Like, don't do simulations, because one of the most important things about IoT is that things doesn't work when you want them to work. You don't understand why it didn't work the last time, and now it works. I mean, that is, I think, essential. And so I'm a little bit, that's why I want to keep, like, I even though it might be not the perfect way of doing things always, like, but I like the breadboard and wires. There are a lot of these plug and play connectors, the Groove connector and that stuff. Super, and I like them as well, but you miss something out of the hard part. And then in terms of protocols and such, well, I think MQTT is still like, you should probably, that is in my understanding, you should know about that. And I think also LoRa is some, I mean, Wi-Fi, we're so used to Wi-Fi, and even though it's a high level, when you write your MicroPython code, you just like a couple of lines and then you're connected. You don't need to think about IP addresses and all that. You just, like, it just works. But with LoRa, you get another dimension. You need to think about, okay, I'm sending some kind of information here now, and maybe I need to use as few bytes as possible. And I think that is, in my experience, very important, because you actually need to think about, okay, I'm actually putting things in the air now, and it needs to be as condensed as possible. And it is received in another end. So LoRa, even though it could be other protocols that are, I don't know, that might be more interesting than LoRa. But in terms of LoRa is a good experience because you are challenged to think, actually, if you work with LoRa, you need to work with MQTT. I mean, you need to fetch the data, and you need to save the data. So automatically you need to think about databases. It's that a lot of the things that you don't need to think about when you're using Wi-Fi, you need to think about when you're using LoRa. At least if you're using the Things network or something like that.
That's great. Yeah, I agreed about regarding the hardware. At the beginning, I was thinking to use software, and there are a couple of platforms that offer a kind of good experience in simulating. But at the end, I went back and say, well, let's work with real hardware. I think it's a more interesting experience for the students. So actually, and what you said, so the nice feeling of, well, today it was not working. Yesterday, you work with yes, that's one.
Yeah. And it's a good way of learning as well. But I think that, it depends probably what you want to achieve, of course. So.
Yeah, okay. So I think, I don't know, no more question, unless if there's any more question. We kept our average of people present during the talk. I think it was very interesting. Thanks a lot. And maybe you can do another one close to somewhere, because as I said, I will see how, maybe I can talk about my experience of another IoT course here in Valencia, and see maybe we can share experiences of that.
Yeah, absolutely.
Okay, so so I think now we are done. Thanks again, Fredrik, for this interesting seminar. Thanks all of you for attending, and see you next month for another great talk here on this channel. Bye-bye, everyone.
Thank you.